Hi everyone, so for this session we are going to discuss system concepts and interactions. Basically, we will describe the system interactions. So let's start. So the forest ecosystem, this is an example of a system is composed of many interdependent parts. So by studying those parts, those interdependent parts, we can understand how similar the ecosystems might function and why. But before we start, let's have first the definition of a system. So systems, including the ecosystems, are a central idea in environmental science. And it is defined as a network of interdependent components and processes with materials and energies flowing from one component of a system into another system. In addition to that one, ecosystem is also a set of components or parts that function together as one. So for example, we have the ecosystem. This is probably a very familiar term for you. I hope you were able to encounter this term. This simple word represents a complex assemblage of a plants. Where could we find the plants? We have here food. Plants could be considered as a source of food. We have the animals here, and the environment itself, which encompasses the non-living things, biotic, abiotic factors. We have the soil, we have water, and we have the sunlight. So this is where the materials and energy move. Now systems can respond in two processes. The first one, we have the linear processes. And the second one, we have the nonlinear processes. So if you add by definition, so let's define what is a linear process. So linear process by definition, this is the addition of anything of the same amount. The change is always the same. What does it mean? If you add the same amount of anything to a compartment in a system, in this case we have the parts of the ecosystem, the change will always be the same, no matter how much you have added before and no matter what else has changed about the system and its environment. So regardless, the change is always the same. Nonlinear process, meaning to say this is the addition of anything in a specific amount. The change will depend on the amount that is being added into the system. So what does it mean? This means that the effect of adding a specific amount of something changes depending on how much has been added before. So we have here, by the way, in this system, it responds to the inputs, and once it responds to the inputs, there would be process that produces an output. So in this case, this is the best example for the nonlinear process. We have the input here. So technically, this is the garbage. So the more garbage we're able to put into the bin, the more smell it can produce. That's the output. The lesser the garbage on the bin, the lesser the smell. Okay, so that's the best example for the nonlinear process. The second one, we have the systems. So we have two types of system. One is the open system and the other one is the closed system. So by definition, closed system. So we have here figures so that you can easily understand the concept. This is closed. So I think this is the bottom part of a Coca-Cola bottle or any soft drinks plastic, a 1-liter bottle merged together. If you are familiar with the term terrarium, that's pseudo system which is being produced. This is a terrestrial system which is the equivalent to the aquarium. So we have the aquarium, diba, in your houses, in your home. So you have your terrarium with the fishes and plants on it. Then we have the water. Same goes with the terrarium. So terrarium, we have the plants. And then what are those terrestrial organisms? It could be earthworm, ants, etc., etc. So this is an example of the closed system. So by definition, for the closed system, no matter moves in and out of the system. So matter, these are the materials, are they solid, liquid, or gas? Although energy and information can move across the system boundaries. Okay, so no matter can move in and out of the system except for the energy and the information in the boundaries here. So technically, of course, the sun here can pass through. Okay, it exchanges no energy or matter with its surroundings throughout, and the best example for this is we have the earth, which is materially closed system. In reality, this is the best example. We have the earth. The second one, we have the open system. So if you try to observe, this is very open, not closed. Technically, our environment works here, no? So we are living in an open system. So by definition, open system, in open system, some energy or material such as solid, liquid, or gas moves into or out of the cell. Of the system. So it will go inside and go outside. It receives inputs from their environment, unlike here in the closed system, it does not. And the best example for the open systems is we have terrestrials, we have oceans, etc. So most of our environment is an open system. In addition to systems, we also have two types of system here. So one is the static system, and the other one we have the dynamic system. So what's the difference between the two? So by definition, static system has a fixed condition. So please take note of the word fixed. So fixed condition, and it tends to remain in that exact condition. Now, when there is a disturbance in the environment, this type of system, the static system, will comes to rest, and exactly it will go back to its condition where it began. What else? And then we have here dynamic system. So dynamic system, usually this type of environment changes through time. So it, of course, in nature, we are living in a dynamic system. It keeps on changing from time to time. So to further illustrate the difference between the static and the dynamic ecosystem, we have here the comparison of a balloon and a hot air balloon. Okay, so ano meron dito? So we have here a birthday balloon which attached to a pole. This one is an example of a static system in terms of its space, in which it stays in one place. However, that is why it is considered as a static system. For dynamic system, we have here the example. A hot air balloon is a simple dynamic system in terms of space, since it moves in response to the winds, air density, and controls exerted by a pilot. Okay, so it changes from time to time. So disturbance, of course, this is what technically this is an example of an environment, and we cannot what do you call this, there would always be disturbances in our environment. It is not static, it is always dynamic. So disturbances, by definition, these are the events that destabilize the system. In this case, the system that we are referring to is the ecosystem. And of course, we always assume that our ecosystem is static. But scientifically speaking, our environment is dynamic. It always requires changes. We want to and should force the ecosystem to be static, when in fact it is dynamic. It changes. Our environment keeps on changing from time to time because of the disturbances that we encounter. Specifically, we have the environmental conditions, catastrophes, events, etc. Another, we have the feedbacks. So feedbacks, by definition, it occurs when the output affects its input. It changes. Now, all the changes in the output gives a feedback on the input. So we have here, this is an example of the process for the feedback. How do we come up with the feedback? So we have the input, and the input, let's say we have here the input, the information, the stimuli was given already, and then it will be processed. So once it will be processed, we have now the feedback, the output, I mean, in which the output where corresponds to the appropriate feedback. And so the cycle will continue. And for feedback, we have two types, the negative feedback and the positive feedback. So by definition, negative feedback, it tends to maintain stability in a system. This is self-regulating. So stabilization, when we say stabilization in the ecosystem, this is negative feedback. Positive feedback, destabilizing. Bakit po? By definition, it occurs when there is an increase in the output which leads to a further rise in a production, or destabilizing. Here, in this next PowerPoint presentation, it explains what's the difference between the negative feedback and the positive feedback. So again, when we say negative feedback, it tends to maintain stability in the system or self-regulating. So meaning to say, stabilize na, homeostasis, so that we can achieve homeostasis. In this case, we have the example here, a body temperature. So a human, you, let's say for instance, this is you as an example. So your body temperature decreases. Usually it happens when you are inside an office where air condition is very it's very cold, of course, or if it's raining. So technically your body temperature will decrease. Now as a response, okay, so that it will process. So as the response of your body, heating process will be activated. So what will you do? You will shiver. So once the heating process is being activated into your body temperature now will increase, so that you will achieve the normal body temperature. Again, stable. So body temperature decrease, shiver, go back, increase temperature, so go back to your body temperature. Here in the right corner, your body temperature increase, and usually it happens if it is too hot, no? So let's say your body temperature is 37 degrees Celsius, or let's say you have a fever, bacterial infection perhaps. So your body will increase from a normal body temperature. You might increase into 2 degrees Celsius or 1 degree Celsius, coming into 38 or 39 degrees Celsius. So what your body will do? So the cooling process is being activated. So if it will be activated, the response of your body would be sweating. Okay, sweating, ito na po yung what do you call this? In vernacular, this is singot. Okay, panington, sweating. So once you sweat, your body temperature now will decrease. So from increased temperature, your body will respond in a cooling process, sweating, and then your temperature now will decreases, go back to the normal body temperature. So ladies and gentlemen, this is how our body works to achieve the negative feedback, the normal body temperature, not only in our body as well as in the ecosystem. Positive feedback, so ito na po yung destabilizing, meaning to say this is not good. Okay, so it occurs when there's an increase in the output which leads to a further rise in the production. So what is the best example here? So we have the carbon dioxide, and we know it already that carbon dioxide is not good if it is too much in the atmosphere. So let's start with the increase of temperature in the environment. Okay, now if there would be an increase of temperature, if it's too hot, usually ganyan po, there would be an increase of fire frequency. So usually last year we have a bushfire in California, and then we also have a fire in the Amazon. So they blame that it was because of the increase of the temperature, and if we have the increase of temperature, of course there would be a tendency of bushfires, no, ganon, forest fires. So if that would happen, so if there would be fires everywhere around the globe, so it will decrease the carbon dioxide storage capacity, because plants are considered as the storage of carbon dioxide. Okay, so they are capable of storing those gases. Now, if there would be a decrease for the carbon dioxide storage, so the tendency, and as a result or the consequence, those carbon dioxide will move into the atmosphere. And once there will be addition of so many carbon dioxide, there will be an increase of atmospheric carbon dioxide. If the amount of the atmospheric carbon dioxide would increase, so technically the result would always be an increase of temperature. So there would be no stability in the system. In fact, this process could destabilize the system. So I think that's it. So I hope you understand our discussion today. From the definition of the systems, we have the responses, which is the linear process and nonlinear. We also have the two types of system, which is the closed and the open system, as well as the static and the dynamic system. The concept of the disturbances. Disturbances, anything that could lead to destabilization of the environment, that's disturbance, either anthropological activity or environmental catastrophe. We also have feedback, which is divided into two, the negative and the positive feedback. So I hope you learned something in our discussion today.